security solution. At any time, you can click on the little Tools icon in the lower right corner to see what additional options are available. This is where you would click, for example, to see the slide notes for this lesson. After completing this lesson, you'll be equipped to identify the business drivers and security challenges that create the need for our data center SDN security solution, describe the customer value of our SDN security solution, identify the Fortinet products and deployment methods included in our data center SDN security solution, and explain the competitive advantage and vertical strategies for our data center SDN security solution. This section begins to tell the story of why Fortinet's data center solution is the best solution for our target customers. Fortinet has been a worldwide leader in global network security appliance shipments for the past several years. When we look at higher-end security appliances, those used in enterprise and service provider data centers, we can see that Fortinet is also a market leader in data center class firewalls. We're currently ranked number 2 and are rapidly converging on the number 1 position. Currently, Fortinet continues to ship more and more data center hardware appliances at an impressive growth rate. We call these technologies and products our North-South data center security strategy. The term North refers to traffic flow in the direction of the Internet, and the term South refers to traffic flow in the direction of the end user. At the same time, customer focus is shifting towards an East-West security strategy. That is, traffic that flows between applications or servers that are located within the data center. This East-West security requirement is driven by technologies such as virtualization, software-defined networking, and cloud computing paradigms. In 2015, Fortinet released many announcements related to partners, products, and solutions around SDN in the cloud. The pace at which these announcements are being made is only accelerating in 2016. The evolution of the data center goes back more than a decade. SDN is just the latest key technology to play a role in the ongoing transformation. The transformation started with server virtualization, first popularized by VMware, consolidating physical servers and then entire data centers for better efficiency. Shortly thereafter, cloud computing paradigms brought more agility and elasticity to compute and storage capabilities in both internal private clouds and public clouds. We saw the rise of infrastructure as a service, IaaS clouds, like Amazon Web Services and Azure, and in software as a service, SaaS, applications. Now SDN is bringing the same benefits of virtualization and agility to the networking layer as well. All of these deployments are making networks more logical and abstract, and traffic flows are becoming more independent of the physical network technology. Network security has traditionally been delivered by physical devices at fixed checkpoints. However, in order to assure that network security can maintain visibility into all flows that require inspection and control, security needs to evolve and to begin to use a more software-defined approach. This means two things. First, security should be viewed as another fundamental layer of data center infrastructure, just like computing, storage, and networking, that can be made agile and elastic. Secondly, security must integrate with and support underlying software-defined infrastructures, cloud and SDN, in this converged and dynamic environment. Let's take a high-level look at the data center security solution. The Fortinet Data Center Security Solution. Let's take a high-level look at the data center security solution. The Fortinet Data Center Security Solution provides a comprehensive strategy to address both the north-south traffic requirements and also the east-west traffic arising due to virtualization, cloud, and SDN technology. Fortinet's approach to east-west security is called Software-Defined Network Security, also known as SDNS. The SDNS framework illustrates how Fortinet's products and technologies are evolving across all layers of the network architecture and how all of the different components work together. Over the next few slides, we'll take a more detailed look at the fundamental components of the framework across the data plane, control plane, and management plane, including virtual appliances and services, platform orchestration and automation, and single pane of glass management. Other advanced aspects of the SDNS framework include additional capabilities for service providers such as telcos and managed service security providers to deliver security as a service in clouds and other managed environments, and platform extensibility through programmatic APIs and other interfaces to integrate and orchestrate with a rich ecosystem of SDN controllers, orchestration platforms, programmable switches, and other vendor platforms of choice. Let's start with the data plane, in other words, your production network traffic. We've taken the same firewall and other security engines from the FortiOS firmware and encapsulated them into virtual firewall appliances. Virtual firewalls, being VMs themselves, can also be placed on hypervisors to gain visibility into virtualized network traffic and can even be deployed to inspect traffic in public clouds where you can't bring hardware. Today, Fortinet supports all leading hypervisor platforms, including VMware, Hyper-V, and KVM. Fortinet also supports leading public clouds, such as AWS and Azure as well. In contrast to scaling up hardware with larger boxes, you can scale out virtual performance by spinning up additional VM instances. The right approach for a given data center will often be a mix of both hardware and virtual appliances, depending on the particular mix of north-south and east-west traffic. Next, let's look at the control plane of the SDNS framework. We can orchestrate firewalls through the control plane to ensure that they're in the right place at the right time. By coordinating with SDN controllers, hypervisors, and other data center management, we can be aware of dynamic changes in the environment, such as a new web or other server workload VM spinning up. This way, we can automatically inspect traffic and data for that workload from the moment it starts up, ensuring no protection gaps. Three of the most popular SDN or network virtualization solutions we support are VMware NSX, Cisco ACI, and OpenStack. Network objects like ports, IP addresses, and MAC addresses are often more logical and dynamic in virtual and SDN environments. Through orchestration, we can also provide more dynamic security policy that follow VMs anywhere in a data center or cluster, regardless of changes in network attributes or even a live migration to a different virtualization host in a cluster. Lastly, we'll look at the management plane. Enterprise servers and workloads should have the same security policies and a consistent and compliant security posture regardless of whether they're running in physical machines or in virtual machines, and whether in internal data centers or across public and hybrid clouds. Fortinet Central Management Solutions for Policy and Analytics provide single pane of glass visibility and policy across physical, virtual, and cloud. SDN, virtualization, and other technologies are fundamentally just architecture, so to understand the benefits, we must look at more specific use cases. One of the most common is when marketing or line of business teams are leveraging agile IT clouds and infrastructure to more rapidly roll out web app or social networking initiatives to connect with end users, customers, or partners. At the same time, it's critical to maintain privacy and confidentiality, as a breach of user data could very well undo the trust and relationships being built in the first place. So ideally, firewalls and network security could be automatically provisioned and scaled to these very elastic workloads, even as they may be rapidly spinning up and down additional web or other service instances to keep pace with viral or unpredictable user activity. A second common use case is microsegmentation. The consolidation of servers and even entire sites into a smaller number of efficient virtualized data centers is a very common part of data center transformations. As more and more servers, applications, and data are being consolidated into these efficient but shared resource pools, there may be an increased risk of a security breach because more and more critical data is exposed, sitting on a typically flat and wide open internal networks. Microsegmentation with SDN and network virtualization leverages a whitelist-based policy model to segment the data center into a fine-grained honeycomb based on users, applications, and devices. It can therefore mitigate the impact and damage of a data breach, limiting the spread of malware and providing sufficient time for IT and security teams to identify and clean up the threat. Now that we've seen the overview, let's look into more specific product information. The anchor products for Fortinet's data center security solution are the physical and virtual FortiGate firewalls. Virtual Fortinet appliances come in different varieties that we'll discuss shortly. There are also additional products such as FortiCore. Now that we've seen the overview, let's look into more specific product information. The anchor products for Fortinet's data center security solution are the physical and virtual FortiGate firewalls. Virtual Fortinet appliances come in different varieties that we'll discuss shortly. There are also additional products such as FortiCore or components such as FortiGate connectors that integrate and orchestrate the FortiGate appliances with the rest of the data center environment. Finally, there are central management products such as FortiManager and FortiAnalyzer that provide a seamless administrative view across data centers and clouds. Fortinet has three fundamental types of virtual appliances: ported, integrated, and cloud. First, there are ported virtual appliances that repackage the same features from hardware in a virtual machine. In addition to FortiGate, there are nearly a dozen functions from FortiWeb to FortiMail to newer solutions like FortiSandbox. These ported appliances themselves are not necessarily aware of the virtual or SDN environment, but instead, orchestration is achieved via additional connector components or API integrations. Second, there are purpose-built integrated solutions that are both aware of and often tightly integrated into the underlying platforms. The key example is FortiGate VMX for VMware NSX, which includes direct API integration to the ESX hypervisor from within the FortiGate. Third, there are appliance packages tightly for cloud environments, such as AWS and Azure, that have additional orchestration and integration to support key cloud features such as self-service marketplace catalogs, on-demand provisioning and billing, and auto-scaling. Next, let's look at how FortiGate physical or virtual appliances can be integrated with key leading SDN platforms, starting with NSX, VMware's network virtualization offering. FortiGate VMX is the name of FortiGate's purpose-built integration for VMware NSX. In this product, the Fortinet virtual appliance, called the FortiGate VMX Security Node, intercepts network traffic via NSX data plane APIs connected directly to the underlying ESX hypervisor. With this unique approach, FortiGate VMX is able to see all east-west traffic between VMs to extend the notion of microsegmentation all the way down to even individual virtual machines. Security groups or zones can be defined completely independent of both physical and virtual switch topology. A central management component, called the FortiGate VMX Service Manager, provides additional control plane orchestration with the NSX Manager to detect changes such as new workloads, enabling VMX to support all other major SDN security use cases, including auto-scaling and auto-provisioning. The second key SDN platform is Cisco's Application-Centric Infrastructure, ACI. Cisco's SDN controller, the APIC, not only provides flow programming of Cisco switches, but also allows the service insertion and chaining of FortiGate firewalls and other third-party Layer 4 to Layer 7 solutions. ACI can program the network flows and switches to redirect east-west flows between workloads to a FortiGate to be inspected rather than directly to its destination on the shortest network path. On the Cisco side, customers need ACI-compatible leaf and spine switches, which today include the Nexus 9000 switches and may soon include the Nexus 7000 and others. In addition, the APIC controller is necessary as it is the central point of orchestration from the Cisco side. On the Fortinet side, customers can orchestrate either physical or virtual FortiGate appliances. They also need the FortiGate connector for Cisco ACI, which provides the integration point. Within the APIC console, as network flows are defined for an application, for example, between app and database tiers of a web application, security services such as firewall and IPS can also be defined as policies within the flow definition. At the same time that the flows are programmed into the Nexus switches, the firewall policies can be configured in the physical or virtual FortiGate appliance. This configuration of both the networking and the security policies in a single pane of glass is very powerful. It ensures that there are no gaps in protection, which is a risk when configuration is done manually after the fact. OpenStack is a major open-source orchestration platform available in standalone distributions or embedded in other vendor products. OpenStack Neutron is the networking orchestration component of OpenStack, and Fortinet leverages the modular Layer 2 plugin interface to automatically insert either a physical or virtual FortiGate in front of VM workloads running on the OpenStack Nova compute nodes. In addition to firewall insertion, one of the benefits of using a physical FortiGate is to replace the Neutron network node. By offloading its built-in network services such as DHCP and NAT routing, we get the performance benefits of ASIC acceleration for both security and network services. Data center class physical FortiGate appliances start at around $15,000 and go up to $250,000 or more. By comparison, pricing and licensing for virtual FortiGates and other virtual security appliances is handled per virtual device or VM instance. Pricing and licensing for virtual FortiGates and other virtual security appliances is handled per virtual device or VM instance, though each is generally smaller in capacity. There are varying instance sizes that could support more CPU, RAM, or other resources to provide higher performance and are priced accordingly. FortiGate connectors that enable orchestration of either virtual or physical FortiGates are typically separate software components and are often an included entitlement without additional cost for active Fortinet support customers. A data center deployment with internal east-west segmentation may typically use several physical appliances to meet bandwidth and connectivity needs, or dozens, if not hundreds, of smaller virtual appliances. very commonly one per virtualization host. Thus, the deal size for a data center may range from $25,000 to $100,000 for a mid-size enterprise, all the way up to $1 million or more for a large enterprise or service provider. Okay, what are the useful sales strategies for the data center security solution? Let's go through some Okay, what are the useful sales strategies for the data center security solution? Let's go through some qualifying questions. One of the first questions to ask is, have you been consolidating your servers or data centers with virtualization, such as VMware ESX? Then, as more and more data is at risk in these shared resource pools, consider a microsegmentation approach to carve up the internal network and mitigate the risk should an advanced threat get inside the network perimeter. Another useful question is, are you looking to bring agility or elasticity to your IT and data center with SDN or other cloud technologies? Then further consider orchestrating your firewalls and network security to enhance and reinforce the benefits of SDN rather than possibly negating them by having to continue to manually configure firewalls after the fact. Yet another useful question is, do you have line of business or marketing teams that are trying to roll out customer or other end-user facing applications, such as for social media or mobile, to connect with your users and accelerate your business? Then make sure you maintain data privacy to retain customer and user trust by automatically and transparently deploying and scaling security to elastic applications without slowing down your business. Let's look at some typical objections and responses. I've been looking into SDN, but it seems like it's mainly for very large and complex networks for companies much larger than mine. Well, agility and elasticity of security and other infrastructure is really something that enables companies to be flexible and adaptable at any scale. Businesses can be nimble in the face of uncertainty or accelerate and outmaneuver competitors when economies are good. We have a fairly static data center environment and manual IT processes, and no one has complained so far. Well, are you sure? Have you encountered any business or app teams going rogue and using AWS or SaaS applications? If so, what was the reason? Were they looking for a more agile infrastructure or applications? We just have an edge firewall in our data center for north-south traffic, and that's worked out fine, even as we've gone from mostly physical to mostly virtual servers. Your virtual teams are generally creating large shared resource pools of compute and storage, concentrating more and more of your data and users into the same shared and often flat network. What happens if you have an advanced threat get inside your network? Do you have your situation where you have all your eggs in one basket? Let's look at some typical insertion points for data center security opportunities. The most common would be an expansion strategy, where we're already bidding on or have won a refresh of existing data center hardware firewalls, which are typically high up at the edge or in the core of the data center network. Once in the data center, it becomes much easier to determine whether there are data center transformation projects, virtualization or SDN, going on in adjacent infrastructure teams. This is where we could potentially augment north-south hardware with additional virtual firewalls for east-west microsegmentation. As organizations increase their adoption of virtualization and cloud, they often embark on wholesale data center consolidation, where they replace many existing data centers with a smaller number of high-efficiency, fully virtualized data centers. In these situations, they're deploying an entirely new infrastructure stack, usually starting from a clean slate in terms of technologies, architectures, and suppliers. This provides an opportunity for us to land net new customers and deployments. Also, as the shift towards public cloud networks begins to accelerate, organizations that were once content with physical firewalls used internally now have no choice but to use a virtual firewall or service for securing workloads in public clouds. In addition to providing virtual firewalls, it's the opportunity to promote centralized management such as FortiManager and FortiAnalyzer to ensure a single pane of glass for policy management across private and public clouds. Telcos and managed service security providers have been very much looking to adopt SDN and cloud technologies, especially for new infrastructure as a service and other managed offerings. Some of their key industry drivers include, as they roll out their own public cloud offerings to compete against the likes of Amazon Web Services, some are looking to differentiate by more tightly integrating security and compliance into their VM offerings, unlike AWS, where you have to go to their marketplace to procure firewalls separately from VMs in EC2. We're seeing a lot of activity now with network function virtualization now replacing carrier-grade hardware with purely virtual network functions for hardware cost commoditization and modularity. By definition, NFV uses 100% virtual firewalls and network functions, which can be inserted and service chained with other network functions like virtual switching or routing. We're seeing interest in using SDN and other orchestration to automate more functions to reduce admin labor, and this is a benefit not just for the large telcos, but agility and elasticity can really provide benefits at any size and scale. Key opportunities and use cases. The first is very much around automating provisioning and onboarding for tenants in multi-tenant clouds and environments. This can not only reduce admin costs, but enable richer security and policy configurations for tenants. Another use case is virtual customer premise equipment, where NFV is used at the customer edge, replacing managed hardware boxes with a small white box that you can quickly deploy and then upsell many virtual network and security services. Key products include FortiGate VM virtual firewalls and FortiGate connectors, especially those for KVM and OpenStack. New VM on-demand utility pricing models can be used, and other new products like FortiCore may come into play for very large-scale deployments. Financial services, particularly the large Wall Street and Main Street banks, are often classic early adopters of new technologies, and we've seen that to be the case with virtualization and SDN as well. Some industry-specific drivers are, first, we're seeing some compliance needs to adopt end-to-end segmentation as a mitigating control for advanced threats inside the network, and this is raising interest in both Fortinet's internal segmentation firewall approach at the physical layer, as well as SDN-based microsegmentation in virtual environments. Second, there's a desire for financial IT teams to be more nimble and agile, partially as a reflection of the larger global macroeconomic uncertainty in recent years. In terms of opportunities, financial firms were often huge adopters of virtualization, VMware in particular, and many have Cisco switches as their network fabric. These large installed bases are driving a lot of interest in both NSX and ACI for software-defined networking, and therefore firewall integration. Also, many of these have been expand rather than land opportunities after an initial proof of concept or win for their data center firewall hardware business enables us to surface new cloud or SDN initiatives more easily. Key products here include FortiGate VMX for VMware NSX and the FortiGate connector for ACI in conjunction with either virtual or physical FortiGates. Okay, we've established the market approaches. How do we compare with the competition? In short, other firewall vendors lack the strategic approach that Fortinet has taken to data center and software-defined network security. Cisco, while having an open SDN platform in ACI, continues to take a proprietary approach to security. Their ASA firewall supports ACI, but not other leading SDN platforms. ASA itself is an outdated firewall-only platform with no clear path for integration, let alone orchestration of IPS and other deep packet inspection from their SourceFire acquisition in 2013. But regardless, one sure thing is that it will be expensive and slow. Juniper is another traditional leader in the data center that has not aged well. Their former high-end NetScreen hardware and installed base face unclear end-of-life and migration plans. Their strategy of acquisition for some of their virtual appliances has led to inconsistent feature sets and unclear roadmaps. And generally, they lack integration with any major SDN platforms except with their own proprietary Contrail platform. Palo Alto has historically lacked the performance to win in the data center. While they're now using SDN in the cloud to penetrate the data center, their virtual appliances are poor performers, and their VMware tie-up biases customer conversations and limits full customer choice. Checkpoint has had inconsistent support of virtualization in SDN platforms, demonstrating a lack of long-term strategy and ecosystem partnerships. Lack of innovation in carrier-grade hardware carries through to virtualization, including missing KVM support. Vendors who were historically strong with physical data center firewall features such as high-speed 40 gig and 100 gig connectivity and carrier-grade features have not necessarily been the most aggressive with virtual and SDN capabilities. Overall, only Fortinet has a comprehensive portfolio for both north-south and east-west security across physical, virtual, and cloud. Let's take a quick look at a customer. Let's look at a customer case study. This customer was a 7,000-employee mid-sized service provider serving 15 countries across Europe. They were one of the first organizations in the region to deploy hardware firewall appliances in their data center. However, they couldn't fully leverage the automation and benefits of ACI when the firewall configuration needed to be done manually and after the fact. They were excited to adopt the FortiGate connector for Cisco ACI, which allowed them to provision FortiGate firewall insertion and richer east-west security policies within each tenant seamlessly and automatically along with the tenant networking. With this additional network and security agility leveraging SDN, they're able to be more nimble and competitive with larger telcos and service providers. In the future, they're looking forward to adopting FortiGate VM virtual appliances to easily scale firewall capacity rather than using VDOM virtual domains within hardware FortiGates. Let's take a quick look at a customer. Let's look at a customer case study. This customer was a 7,000-employee mid-sized service provider serving 15 countries across Europe. They were one of the first organizations in the region to deploy hardware firewall appliances in their data center. However, they couldn't fully leverage the automation and benefits of ACI when the firewall configuration needed to be done manually and after the fact. They were excited to adopt the FortiGate connector for Cisco ACI, which allowed them to provision FortiGate firewall insertion and richer east-west security policies within each tenant seamlessly and automatically along with the tenant networking. With this additional network and security agility leveraging SDN, they're able to be more nimble and competitive with larger telcos and service providers. In the future, they're looking forward to adopting FortiGate VM virtual appliances to easily scale firewall capacity rather than using VDOM virtual domains within hardware FortiGates. For more information, visit the Fortinet SDN and Network Virtualization Solution page where you'll find collateral and resources including a software-defined network security solution white paper and solution briefs on VMware NSX, Cisco ACI, and OpenStack integration. Also, visit the Fuse community for data center security to see the latest discussions and assets. With some of our key SDN integrations, we have strong and growing partnerships with organizations such as VMware, Cisco, and HP Enterprise. On the website and on Fuse, you'll find numerous white papers, collateral, and other assets that are co-branded with our key partners to reinforce the complete and integrated solution stack with both Fortinet and the partner technologies. Let's quickly review the main points of what we've covered. First, Fortinet is a leading vendor of data center firewall appliances. However, customer requirements are shifting to east-west security. This requirement is being driven by data center transformations that include virtualization, cloud computing, and software-defined networking. Security is another fundamental layer of data center infrastructure that needs to become software-defined, agile, and elastic. Fortinet is delivering the most comprehensive solution framework for SDNS. Finally, Fortinet's integration with leading SDN platforms such as VMware, Cisco, and OpenStack enables the orchestration of both physical and virtual security appliances. Now that you've completed this lesson, you should be armed with the knowledge required to identify the business drivers and security challenges that created the need for the data center security solution, describe the customer value of the data center security solution, identify the Fortinet products and deployment methods included in the data center security solution, and explain the competitive advantages and vertical strategies of this solution. Thank you for your time.